All right, welcome to the solution walkthrough for Objective 7, solving the Sleigh's candy bus problem. And this involves using filtering techniques to discover some false or injected values on the bus that we need to filter out so that the Sleigh works properly. So let's just jump right in here. So Jack Frost is somehow inserting malicious messages onto the Sleigh's candy bus. Okay, CAN bus. We need you to exclude the malicious messages and no others to fix the Sleigh. Yeah, so I believe if you talk to this elf as a non-Santa character, you do get a hint that basically tells you what components you need to be looking for, which I think it tells you the brakes and the lock unlock. So that just points you towards what to look for. But basically, Jack Frost, yeah, he's inserting some messages onto the bus. We need to filter those out, and once we do, the objective unlocks itself or solves itself. So if we launch this, we get some sort of like a tablet interface. We've got some CAN data that's scrolling here live. Really what we want to pay attention to is the arbitration ID here in this column and the message, the actual CAN data being represented here. Right now we're getting a bunch of zeros. Some of these F2057 messages coming through. It's a lot of fast scrolling data. So the way I approach this challenge is let's use this filtering tool in the middle here to start filtering out some of these like zero lines, just to, I guess, slow down the display and make it show only values that don't have a message of zero. So as these are scrolling by, I'm trying to identify some of the arbitration IDs. I can see, let's see, 244 in there. So 244, if it equals to all zeros, let's exclude it. What other ones do we see? I see 080. Let's exclude that one. So you can see the refresh rate or the scroll rate is getting slower as we filter out these CAN frames. 019 appears to be one. Let's filter that one out. 188. Let's filter that. And now it's completely stopped. So that means we're basically, for the most part, filtering everything except for this non-zero value. So to me, that's kind of a red flag right away. That just appears to stand out. And we'll see soon that this is actually one of the injected messages. But anyway, if we look at the rest of this tablet, we see we've got some controls here. We've got a tachometer here. I'm showing our RPM. So we've got sliders here for accelerator, brake, and steering left and right. And then we've got start, stop, lock, and unlock. If we do lock and unlock, we can see that we cycle between all zeros and this message with a F in the middle. So that appears to be our exact frames for locking and unlocking the vehicle. If we go ahead and do a stop, this appears to be the frame needed to stop, and then start, that appears to be the frame for starting. Now we can see that the Sleigh is up and running. The RPM is hovering between different values here, so it's totally normal to see those random values up there under arbitration ID 244. So that probably is associated with the engine, the RPM. So that's cool. So I'm not seeing anything out of the blue there. Still seeing this field, which is very sketchy. So let's try to figure out what arbitration ID 19B is responsible for. So let's go ahead and filter out 244. We can use the all filter, and that'll just take everything out of 244. So now let's play with this steering. Okay, no, so 019 seems to correlate to steering. So you know what? I'll just leave that as such. 19B, what is that for? Oh yes, our lock unlock. Okay, so we know arbitration ID has to deal with unlock and lock, and we know our two values for that are all zeros and one with the F in the middle. So this one definitely stands out as being injected. We're not doing anything, and that just keeps popping up. So let's go ahead and filter that out. So what we'll do is type in the arbitration ID, which is 19B, and then the exact data for that, which is going to be 5720, and then an F, and then we'll leave the rest of this blank, and we'll hit exclude. Okay, so now we're excluding that, so we shouldn't see this value come up anymore. Okay, and then we've got one more injected value that we need to discover and remove. So if we start playing with the brakes, yeah, if we apply the brakes versus actually shutting them off or not using them at all, so not using them at all, nothing happens. If we turn the brakes on, apply them, whatever, we do see some conflicting values. So we're getting like low numbers, like hex 26 versus hex FFFFF. Now if we turn the brakes all the way up, that low, I guess low positive number turns from hex whatever 20 to hex 64. So to me, this FFFFFF value is standing out. It doesn't align with how the slider scales, and also that FFFFF value is as a signed integer, it's actually a negative value, and it really doesn't make sense in the context of this challenge to have a negative value for brakes. So just by really trial and error, because I wasn't sure when I was initially going through this challenge if my assumption on that was right, what I did is I just created a filter for less than 0, because what happens is this OX hex value for this FFFFF, and then whatever's at the end, like the FD, those are basically just very small negative integer values. They're not positive, so that's the way that the data is represented or interpreted. And that has to deal with 2's complements, and just how signed integers are represented in hexadecimal and also binary. So anyway, yeah. So I go ahead and apply that filter, and you can see now we only see this like small positive value. So if we tweak the brakes here, it makes sense that as we go up, so does the hexadecimal value here. And actually, hex 64 is decimal 100. So I can show you here with the programmer calculator. If I were to type in hex 64, that is decimal 100. So this is correlating exactly, for example, with the brake value that we're setting here. So hex 30 should be integer 48, and it is. Okay, so to solve this challenge now, we have actually the 2 filters that we need. You would either know that by the hint or just by trial by error, or trying and repeating until you solve the challenge. But yeah, you can go through the rest of these, like the accelerator, the steering, the starting, the stopping, and there's no other seemingly injected or outstanding messages that don't make sense. So what we need to do for this challenge to register as complete is remove these other filters that we applied to slow down the rate of data. So we'll just go ahead and remove these filters so that real data comes back. And at this point, you see Sleigh defrosted, and you would get the message saying you've unlocked this challenge. So that is it. If a lot of this didn't make sense with like the arbitration IDs and stuff, look for my other video on the CAN bus, the terminal challenge. I believe in the description of that video, furthermore, I have a link to my B-Sides talk on Introduction to CAN bus hacking. So depending on how deep you want to understand this and more, you can check both those videos out. So But in addition to that, if you have any questions, let me know in the comments, and we'll see you in the next video.